So we are going to start the second chapter, inverse trigonometric function. As the name indicates, we are going to deal with the inverse of the trigonometric functions. Okay, so do you remember what I meant by an inverse function? Suppose f is a function from x to y. Then if g is a function from y to x such that f composite g is equal to I, then g is called an inverse function that we have studied in the first chapter. Okay, and in the first chapter we also studied that for a function to have an inverse, it must be 1, 1 and onto. If f is 1, 1 and onto, then 1, 1 and onto, then it has an inverse, isn't it? That means f must be bijective to possess an inverse. So these are the basic ideas which we are going to apply in this chapter. Okay, so first we will deal with the inverse of sine function. Sine function is a function defined from R to closed interval minus 1, 1. Isn't it? Sine function is a function with the domain R and range as minus 1, 1. To find the inverse of sine function, we have to consider a function from minus 1, 1 to R. Okay, so if I am considering a function from minus 1, 1 to R, to make this function or to find the inverse of this function, first we need to check whether it is 1, 1 and onto. If I am defining sine 0, what is sine 0? Sine 0 is 0, isn't it? What about sine pi? Sine pi is also 0. What about sine 2 pi? Sine 2 pi is also 0. So if I am drawing this at 0, I am drawing the first function from R to closed interval minus 1, 1. So sine 0, it is mapped to 0. Sine pi, it is mapped to pi. The function I am defining is sine function. If I am taking 2 pi, it is again mapped to 0. If I take 3 pi, 4 pi, 5 pi, all have the image 0. That means the function is not 1, 1. If the function is not 1, 1, the inverse function does not exist. We are not able to find the inverse. Okay, so in this case, to find the inverse of a sine function, what we are going to do is we are going to restrict the range of this function instead of R. This is the sine function. To find the inverse of sine function, what we are going to do is we will take the domain as minus 1, 1. We are going to restrict the range R. Instead of R, we are going to break the range in the intervals as intervals. We are going to break the intervals as minus pi by 2, comma pi by 2, in which the function will be 1, 1. Sine function will be 1, 1. Same way, the next interval I can take is pi by 2, 3 pi by 2. The next interval I can take is 3 pi by 2, 5 pi by 2. In all these cases, if I am defining the sine function in each of these intervals, there are so many intervals in each of these intervals, then sine function is 1, 1 and onto. Then we can have the inverse. So we are restricting the function. Instead of taking R to minus 1, 1, we are restricting the function sine from, if I take the first interval minus pi by 2, it's not actually the first interval which I wrote. So we are defining the sine function from minus pi by 2 closed interval minus pi by 2 to closed interval minus 1, 1. So this function will be 1, 1 and also onto. That means this function has an inverse. Same way, instead of closed interval minus pi by 2, I can take closed interval pi by 2, 3 pi by 2. Then also the function will be 1, 1 and onto. Same way in the case of all the intervals. So what we do is to make the sine function 1, 1 and onto, we are restricting the domain of the sine function instead of R as interval so that the inverse function exists. Okay, sine inverse, the inverse of sine function is denoted by sine raised to minus 1 x. Minus 1 comes in between n and x and it is written on top. And it read as sine inverse x. Sine inverse is a function defined from any of these intervals to closed interval minus 1, 1. Okay, but in this chapter we are not going to deal with all these intervals. We are going to deal with only minus pi by 2 in the case of sine. Minus pi by 2 closed interval minus pi by 2 to minus 1, 1. This interval in the case of sine function is called by the name principal value branch. Principal value branch. You have to be thorough with the principal value branch of all the 6 trigonometric functions, and only you will be able to calculate the values which comes inside the principal value branch. So in case of sine inverse function, the principal value branch is closed interval minus pi by 2, pi by 2. Okay, so sine inverse is a function. In this chapter, we are going to define sine inverse as a function from minus pi by 2 to minus 1, 1. And this minus pi by 2 closed interval minus pi by 2 is called the principal value branch of sine inverse. For each trigonometric function, it will have different principal value branch. In the case of sine function or sine inverse, the principal value branch is minus pi by 2, closed interval minus pi by 2, pi by 2. Okay.